So now we are down to our conclusions. So our first conclusion, any two consecutive counting whole numbers added together result in an odd number. For our conclusion number 2, three consecutive counting whole numbers added together generate a sum that is a multiple of 3. For our conclusion number 4, the sum of 6 consecutive whole numbers is divisible by the sum of middle two numbers. Example for this is 6x plus 15 equals to 3 multiplied to the quantity of 2x plus 5. So for our fifth conclusion, any counting number that is not equal to 1 and 2 raised to the power of n can be expressed as the sum of 2 or more consecutive counting whole numbers. So when you are going to encounter numbers that is not 1 and 2 raised to the power of n, you can conclude that it can be expressed as the sum of 2 or more consecutive counting numbers. For our fifth conclusion, the sum of 2 or more consecutive counting numbers with odd number of terms, we are going to use the formula s equals to n multiplied to n, where n is the number of terms, m is the median of the sequence, and s is the sum of the consecutive terms. So for our conclusion number 7, the sum of the 2 or more consecutive counting whole number with even number of terms, we are going to use the formula s equals to n multiplied to the quantity of n sub 1 plus m sub 2 over 2, where n is the number of terms, m sub 1 is the first median of the sequence, m sub 2 is the second median of the sequence, s is the sum of the consecutive terms. For our eighth conclusion, any counting number that is not equal to 1 and 2 raised to n can be expressed as the sum of 2 or more consecutive counting whole numbers in one or more ways.
As a result, the researcher or the investigator was able to determine that the formula they had created would enable them to determine the total or the sum of 2 or more consecutive whole numbers. And also, that formula is helpful in finding if a specific number or specific counting number can be expressed as a sum of 2 or more consecutive numbers, because if its x is a whole number, therefore it can be expressed in that specific number of term. But if its x is a fraction, therefore it cannot be expressed as that specific number of term if it is a fraction or if it is not a counting whole number. To be specific, also, a number cannot be written as a sum of 2 or more consecutive counting whole numbers if their sum is 1 and if their sum is 2 raised to the power of n, such as 2, 4, 8, 16, 32, and so on. The researcher also noted that the sum can be stated in different ways. For example, the 9, it can be expressed in 2 ways. 15, it can be expressed in 3 ways. However, since the researcher also only focused on the formula and determining, the researchers recommended further study on the number of ways each consecutive counting number can be expressed. For example, in how many terms, in how many ways can 15 be expressed, in how many ways at 26 can be expressed. So the researcher recommend to study further on that. And a number, and how many terms a number needed in order for them to be expressed as the sum of 2 or more consecutive number. For example, 15, how many numbers can be as needed, or how many numbers is needed in order for it to be expressed as a sum of 2 or more counting numbers. So that is the recommendation of the researchers for further studies. And these are our references. As you can see, we have the definitions of counting whole numbers, and also we also have some of the and these are the references of the researchers. So that's all for our research presentation. Thank you everyone, and thank you for listening, and God bless.